Alright, so in the last video we talked about switching between exponential and logarithmic, and now to continue this lesson we're going to talk about evaluating logs. So our first step, 1, is to convert to exponential form, and then 2 is to find the exponent that makes the equation true. So again, if you need that kind of refresher, if we do a log of some base evaluated at an answer equals x, switching around, we start with the base to the exponent equals the answer. So that gives us b to some x equals the answer a. So here we did base, so 3. Well, it wasn't equal to anything, so I'm just going to say 3 to something gives us 243. Well, how many times do I need to multiply 3 to get 243? Well, 3 times 3 times 3 is 27, so obviously I need more than that. So let's try 3 to the 5th. Well, 3 to the 5th, I checked it with my calculator, I got it. So question mark is 5. Sometimes I like to call this x instead, just so that I'm solving for something. Alright, so again, we're thinking about here, 8 to some power gives us 512. So 8 to some power equals 512. Well, what power? 8. Let's do 8 to the 3rd, see what that gives us. It ended up working. So question mark equals 3rd. 8 to the 3rd power gives us 512. Alright, so continuing on, 4 to what power gives us 1/16? 4 to what power equals 1 over 16? Well, the fraction tells me I probably need a negative exponent. So remember, fraction, negative exponent. Well, I know 4 squared is 16, so then I probably need 4 to the negative 2nd equals 1 over 16. Well, that's 1 over 4 squared, so yes. So negative 2 is my answer. Alright, I want you to try this one. Alright, and then we're going to move on to the next one. So 1/2 to some power gives us 8. So 1/2 raised to some power gives us 8. Well, again, I see a fraction, so I'm not equal to a fraction, so I probably need a negative exponent again. So again, negative exponent. So if I do 1/2 to the negative 1, I get 2 equals 8. But I don't need 2 equals 8, I need 2 to some power equals 8. Well, it's the 3rd power, so question mark equals 3, but again I have that negative, so I need negative 3. And you can check this with your calculator too. So you can do 2 to the negative 3rd, and you get a fraction, or a decimal, turn it into a fraction, 1/8. Well, again, I started with 1/2, so I actually need 1/2 to the negative 3rd, so it checks out. So negative 3 works. Alright, now I've got, remember, natural log has that base e. So e to what power gives you e to the 4th? Well, that's that 1-to-1 property there. All I have to do is set the exponents equal. So question mark equals 4. 4 is my answer. Alright, I need e to some power gives me 1. So e to what power equals 1. The only way to get 1 is the 0 power. So to get 1, need power equal to 0. So 0 is the answer here. And finally, we got 49 to some power gives us 7. 49 to something equals 7. Well, what's the relationship between 7 and 49? Well, I know 7 squared equals 49, but that's not what I want. I want 49 to something gives us 7. Well, hopefully you're thinking square root. So, square root equals power of 1/2. So your question mark actually equals 1/2 here. The square root power. Alright? And then lastly, we've got some logs here. Sometimes they're not as intuitive. So we got base 10. 10 to what power gives you 16? I don't know about you, but I don't think I can get 10 to be 16 anyway. So I'm stuck. Use calculator. I can actually type in my calculator a logarithm. Right here under x squared is log. Hit log, I'm evaluating. Now this is base 10, so you got to be careful about the base. It only works in base 10. I get 1.204. So question mark equals 1.204. And then again here, I've got e. Well, e to some power gives us 6.52. I don't know about you, but again, I'm stuck. So I'm going to type in my calculator. Right under log is the natural log, 6.52. And I get an answer. So I've got 1.875. So that's my answer there. Alright, this last part of topic 1 for 11.2 is going to be pretty quick. So, inverse functions, our last goal. It is just like finding inverses from previous units. So, our steps are literally the same exact steps that we had before. First, we're going to change it to y equals. After that, you're going to switch x and y. Once you've switched x and y, we need to solve for y. So solve for y. This is where it branches. If it's exponential, or if it starts exponential, we might need to go exponential to log. Or if it's log, we might need to go to exponential. And finally, in the end, just make sure to change to inverse notation. So let's just put it in action so that we can figure out what we need to do. Step 1, write as y equals. So y equals 5 to the x. It starts as an exponential, so I need to make it a logarithmic. So remember, the base to the exponent equals your answer. So I'm going to change 5, or log base 5. Oh, I didn't switch x and y yet. Never mind. We need to switch x equals 5 to the x. 5 to the y, my bad. Now we can change. I was trying to go a little too early. 5 to the x equals y. So log base 5 of x equals y. And we've solved for y. So solving for y, you have to change forms, basically. Finally, inverse notation. We've got g inverse of x equals, so I'm replacing this, log base 5 of x. Alright, and we're going to do one more example together, and then the last two are going to be for you to try. So change y equals log base 2 of x. Now don't be like Millikan and forget to change x and y. And again, I'm logarithmic, so I need to go to exponential. So the base to the answer equals the exponent. So 2 to the x equals y. And again, I'm going to change. We had f inverse of x equals 2 to the x. And then I'm just going to kind of draw a dividing line down here so we can tell that those are two separate equations. And again, these two are for you to try out doing the inverse on your own.